Let's take a look at UplinkFast first. UplinkFast is a feature that needs to be enabled globally on the switch. When it's enabled, it is going to be enabled on all the ports and all the VLANs on the switch. I should point out that configuring UplinkFast on the root switch is completely pointless and should be avoided. Once the feature is enabled, a couple of things are going to happen on the switch. The first, the bridge priority on the switch is going to be increased in an attempt to avoid the switch from becoming the root. The value that it is going to be set for the bridge priority is going to be 49,152. Also, the cost on all ports will be increased by 3,000. This is done in an attempt to avoid the switch from becoming the transit switch. We don't want this switch to pass the traffic for other switches. We want it to be a leaf node. When UplinkFast is triggered, that means when we have lost the uplink port that we used as the root port, a couple of things are going to happen. First, the best alternate port is going to be immediately promoted to the root port. And you should note that I put the alternate there under quotes, because alternate has a special meaning when used in combination with rapid spanning tree, and this is not it. By alternate here, I simply mean a port that is not the current root but is receiving BPDUs. In other words, it's not a designated port. When we receive BPDUs that match BPDUs that we are using on the root port, that means that they are sent by the same route, they have the same priority and so on, but they are not as good as those received on the root port. In other words, the cost is slightly higher, or maybe the port priority on the other side is higher. In that case, those ports are going to end up being in a blocking state. When that happens, the UplinkFast feature is going to actually keep track of all these ports. And when the root port disappears, when we lose the connection to the other side, when that port fails, what the switch can do is it can look at the stored copies of BPDUs received on those, quotes, alternate ports, and it can determine which one of these uplink ports can actually be promoted to become a root port. And that happens immediately. It is going to bypass both listening and learning phases and go immediately into the forwarding state. The reason why it can bypass those two transient states is because the switch knows it's a loop-free environment, because it keeps track of all the BPDUs, not only the superior, the best BPDU. Another thing that is going to happen when this is triggered is that the switch is going to try to spoof the traffic from the hosts it knows about. Remember that switches learn the MAC addresses of all the hosts that are transmitting, that are sending the traffic through the switch. These MAC addresses are stored in the CAM table. When UplinkFast is triggered, the switch is going to start sending bogus traffic from these hosts. So the switch is going to send the traffic as if it was sent by these hosts, and it's going to be sending them out to a special multicast destination. That means that this is most likely not going to be end up as used by anyone in the network. The only reason why we are doing this, why the switch is doing this, is that the uplink switch, the one that is now that has now been promoted to the root path, can actually learn the MAC addresses on the new port. So we are doing that to avoid unnecessary unicast flooding through our network. I know that this is a little bit too much to digest by just imagining it, so let me show you an example on the whiteboard first, and then we are going to take a look at how UplinkFast actually works on the switch. Let's consider a network consisting of 3 switches. These switches are going to be Cat1, Cat2, and Cat3. And let's say that these 3 switches are interconnected in a triangle like this. Let's also assume that Cat1 here is the root. And behind Cat3 here, we have some hosts. Let's say that these are hosts A, B, and C. Cat2 here has a gigabit link towards Cat1, and Cat1 has a gigabit link towards Cat2. These here links are all fast Ethernet, so this is fast Ethernet and this is fast Ethernet here. The resulting spanning tree topology here would be that this here will be designated port, this here would be designated port, this here will be a root port, this here would be a designated port, this here would be a blocking port, and this here would be a root port. So we can say that this port here is actually not sending any BPDUs. This network is going to function normally. And let's say that the link between Cat1 and Cat3 fails. When this happens, the interface between Cat3 and Cat2 needs to transition from blocking state to listening state. Then it needs to transition to learning state. And finally, it will transition into a forwarding state. In the listening state, it will spend 15 seconds. In learning state, it will spend 15 seconds, which means that this transition here is going to take 30 seconds. When this link here comes back up, this link now needs to transition to the forwarding state. This one here will be immediately blocked, and now this link here facing Cat1 needs to go through this transition. That means that for about 30 seconds in this failure scenario, we are not going to have any traffic reaching hosts A, B, and C from any hosts behind Cat2 or Cat1. This is clearly not very optimal solution. So let's turn on UplinkFast on Cat3. So now I'm going to enable UplinkFast. And let's see how things are different, if they are indeed different, in comparison to our previous example. So I'm going to remove this transition here as if it never happened. And let's say that this link here now fails. What's going to happen now is that the BPDU that was being sent by Cat1 to Cat2 was being tracked by Cat3. And Cat3 now knows that this is an alternate path. So this interface here is going to transition from blocking to forwarding state immediately. So there is no delay. Furthermore, what's going to happen is Cat3 is going to consult its CAM table about hosts A, B, and C, and it's going to start generating the traffic sent towards Cat2 with the source MAC address of, let's say, host A, and the destination MAC address of a special multicast address, which is 0100 0CCD CD. It is also going to do this for A, B, and C. And by default, this will be sent at the rate of 150 packets per second. The reason for this is that we want Cat2 to actually learn these MAC addresses here and actually unlearn these MAC addresses from this port here. When the link between Cat1 and Cat3 recovers, so this link returns now, we are going to have very similar operation happen. This interface here is going to now transition immediately from forwarding to blocking, and this interface here is immediately going to transition from disabled to forwarding, and the same thing here is going to happen. We are going to start flooding the traffic on this interface here towards Cat1, making sure that Cat1 actually learns these MAC addresses here, and by the same virtue, because these are multicast frames, they're going to go out to Cat1, they're going to be reached, they're going to reach Cat2, so Cat2 is going to learn them from here and actually unlearn them from this interface. So you can see how UplinkFast can improve the performance. Let's try to see it in action. To do that, I'm going to build the network that looks almost identical. I'm going to use Cat1, Cat2, and Cat3 configured in a triangle like this. The interconnection between Cat1 and Cat2 is using gigabit 01 interface on both sides. The connection between Cat2 and Cat3 is using fast Ethernet 020, and here I'm using fast Ethernet 022, and my Cat1 will be configured to be the root. Let's take a look at this. So here I am on my Cat1. I'm going to say show spanning tree, and what I should be seeing now is the connection with my Cat2 on gigabit Ethernet 01 and the connection with my fast Ethernet 022. This will be my Cat3. I also have some hosts connected to this network just to maintain my spanning tree up and running if I decide to bring these interconnecting links down. Also, I can see that Cat1 is the root. If I go to Cat2, if I take a look at the show spanning tree, I will see that the gigabit Ethernet 01 is the root port. So let's mark our ports here on our diagram. So on Cat1, this will be the designated port, this will be the designated port. I can see that this is the root port, and also I can see that fast Ethernet 20 is the designated port. So I'm going to mark it as such on Cat2. Going back to Cat3, I'm going to do show spanning tree here, and I should be seeing that fast Ethernet 22 is the root port. So this one here becomes the root port, and the fast Ethernet 20 is in a blocking state. Also, I have two hosts connected to Cat3. I have host A, which is, actually, let me mark it correctly. This is my router R4, which is connected on fast Ethernet 04, and the only reason I need it is to have this interface up, no other reason. I also have to Cat3 connected a Wireshark station on fast Ethernet 03 interface that I'm going to use to observe what is happening on my network when I initiate the failover. Let me quickly configure that. So I'm going to go to my terminal, and on Cat3 I'm going to say monitor session 1 source interface fast Ethernet, what am I looking at? Fast Ethernet 20, and I'm only interested in traffic being sent there. And I'm going to say monitor session 1 destination interface fast Ethernet 03 encapsulation replicate. I want to preserve all the VLAN tags there. So if I do show monitor, I'm going to see that my monitoring is now enabled, and if I repeat the command show spanning tree, now I can see that fast Ethernet 03 has disappeared. I only have these three interfaces now. So this is without the UplinkFast configured. If I do show spanning tree UplinkFast, I will see that UplinkFast is disabled. I'm going to go to Cat1, and I'm going to shut down the interface facing Cat3. Let's see what happens there. Before I do that, I'm going to go to my Wireshark, and I'm going to start the capture. I want to see what is happening with the traffic. I should be seeing very little traffic. I may see the keep alives or DTP frames. I may see CDP frames. So what I'm going to do here is I'm just going to make sure that I'm not seeing any of these. So I'm going to say not loop and not CDP and not DTP. So these are the frames that are periodically going to show up, and I really don't care about them. So the next thing that I'm going to do now is I'm going to go to Cat3, and I'm going to run show spanning tree. I haven't shut down the interface yet. So here I see that fast Ethernet 20 is in blocking phase, in blocking state, and I can see that fast Ethernet 22 is the root forwarding. So I'm going to go to Cat1, I'm going to shut down the port facing Cat3. When the interface goes down, if I repeat show spanning tree, I will see that fast Ethernet 20 has now transitioned into listening phase, which means that if I had any other host on this network behind my Cat3, and if I wanted to communicate to a host that was, say, here behind Cat2 in the same VLAN 1 in this case, I wouldn't be able to do so. Let's see what is happening in our Wireshark. What is happening in Wireshark is that I have sent topology notifications, and by I actually mean Cat3. So there are some topology change notifications that went out as the result of the change. So if I go back to my terminal, now I can see that in the meantime, this port has transitioned the state to forwarding. This took about 30 seconds. Let's bring up the interface between Cat1 and Cat3. So the interface is now going up, and I'm going to repeat the show spanning tree command when the interface comes up. So here it is, and take a look at this situation here. I have the port, FastInternet22 is now root port, but is in listening state, and FastInternet20 is now in blocking state. And this is going to remain like this for the next 30 seconds. So now I'm in learning state, and eventually I'm going to transition into forwarding, even when the link came back up. So now there are no links down. I have problems behind Cat3 here, and only now I can see that the port has transitioned into forwarding state. What is happening in our Wireshark? As you can see, not much, because the blocking port, this one here, is not transmitting any BPDUs. So this was convergence without the UplinkFast. Let's turn on the UplinkFast on Cat3. So what I'm going to do now on Cat3 is I'm simply going to say spanning tree UplinkFast. As you can see, not much happens, actually nothing at all. But if I do show spanning tree UplinkFast, now I'm going to see a couple of things. I'm going to see, first of all, that UplinkFast has been turned on, and I can see that the station update rate is set to 150 packets per second. Remember, these are going to be those spoofed packets. I can change this rate here at spanning tree UplinkFast. I can say maximum update rate, and I can set the update rate that I want this switch to use to generate those spoofed frames. I'm going to leave this at default. Also, let me repeat the show command. I can see a couple of statistics, how many transitions have happened so far on this switch using the UplinkFast, and how many proxy multicast addresses, I like to call them the spoofed addresses. Cisco calls them proxy multicast addresses. Well, okay, good for them. And here I can see in which VLAN, what is the actual root port. So this here, I know it's a root port because it says forwarding, and also what are the other interfaces on which I'm receiving BPDUs. So now I know that my FastInternet20 is a port that can be used for alternate failover. So let's take a look at the output of our show spanning tree here, and I can see that the situation is as it was before. I have FastInternet22 is a root port in forwarding state, and FastInternet20 is in blocking state. Let's go to Cat1, and let's bring down the interface. Before I do that, let's go to our Wireshark. I'm going to restart the capture to have a clean slate there. So I'm going to go to Cat1, I'm going to do shutdown, going to go to Cat3, and as soon as I do show spanning tree, I can see that FastInternet20 transitioned immediately into the forwarding state. Also, please note one thing, I didn't mention it before. Take a look at the cost before we shut down the interface. It's 3019. Remember what I mentioned before, that the UplinkFast will increase the interface costs by 3000. This is where we see this. Also, we can see here that the bridge priority has been changed to 49,152. So it will be effectively 49,153 because of the extended system ID. When I shut the interface down, I got this log message here telling me that the port is actually going to be moved to the forwarding state due to the UplinkFast failover. Also, let's take a look at our Wireshark. Now, there is more than just the TCN there. Let me show you something. On Cat3, if I do show MAC address, interface fastnet04, this is the MAC address that was learned from my R4. So this is the host in VLAN 1. This is the MAC address learned. If I go back to Wireshark, take a look at, for example, this frame here. Look at the sender of the frame. Look at the MAC address of this frame. It is actually something other than what I expected, so I would have to figure out where this MAC address was learned from, but this is the one actually that we should be looking. Sorry about that. So this one here, 000A581AB179. So this is the one, 51795179. This is the frame here. Look at the source, look at the destination. 01000C CD CD CD. This is the frame that switch generated in order to make sure that the uplink, that the new uplink switch actually learned this MAC address on the correct port. Let's go back to our Cat1. So on Cat3 here, before I do anything on Cat1, let me just show you, show spanning tree, UplinkFast. Here now we can see that there was a one transition and there were quite a few frames being sent out as the result of that. I haven't really talked about it, but we can see here some of the weird looking frames. For example, this one here. Switches are designed to support non-IP traffic, like the Apple Talk, like IPEx, LLC, and so on. So the switch is going to generate the frames in all these protocols in a case that end stations are using something other than IP. I know, it's relatively useless in this day and age, but this is what switches do anyways. So I'm going to go back to Cat3 and I'm going to repeat show spanning tree. And I can see that Fast Ethernet 20 is a root port in a forwarding state. Let me go back to Cat1 on interface Fastnet 22 and I'm going to do no shutdown. When I go back to Cat3 and if I repeat my show spanning tree, when this interface comes back up, I'm going to see now that Fast Ethernet 20 didn't immediately transition to blocking state as before. It remains forwarding while Fast Ethernet 22 goes through its own motion. So I'm now waiting to hear the superior BPDUs on that interface. And this is going to happen in very, very short time. So let's be patient for 30 or so seconds for this to happen. The reason why this is happening, of course, is on Cat1. We need to wait for this to transition to the forwarding state. Just happened. Now, when it transitioned to the forwarding state, when we start getting the BPDUs in our listening and learning states there, we can see that now UplinkFast actually moved this interface to forwarding state. And if I repeat the show spanning tree, I will see that Fast Ethernet 20 is now blocking and Fast Ethernet 22 is now forwarding. As you can see, the failover time for Cat3 and the host behind it was much, much better than without the UplinkFast.